This tutorial will guide you through creating Lewis dot structures for polyatomic ions, many atom ions. We've been presented these. This is not neutral. There physically was an addition of an electron that we perceive belongs to the whole entire structure. So whenever we construct the Lewis dot diagram, it has to reflect that. I'm going to lead us through the method that I encourage us to use, which will lead us most directly to the correct answer. Okay, this is called hydroxide. We will learn the name to come. We have oxygen and hydrogen, so I'm first going to place them next to each other. Oxygen, of course, with 6, hydrogen with its 1. But before I start to do any bonding, I'm going to take care of this charge. This has picked up one more electron, and I need to show that. If we have gained or lost electrons, I suggest taking care of that on the center element. Well, there isn't a center element here, so since this is gaining an electron, I'm going to assign it to oxygen, the more electronegative. It makes more sense that oxygen would have the greater pull for it than hydrogen. So we're actually going to start with oxygen having 7. Well, hydrogen, we know, will make a single bond with oxygen. Well, that satisfies oxygen's octet. I am just going to bring that lone electron over. So now my oxygen has 3 pairs. My hydrogen is satisfied with a sharing. So it has 2, oxygen has 8. But we're not done, because anything that is carrying an extra electron or is under electrons to make it neutral, in Lewis dot, we must include it in brackets and show the charge as an exponent or superscript. That's hydroxide. Let's move on to ammonium. Nitrogen is our center. It would get assigned 5 valence electrons. We have 4 hydrogens. Each of those brings in 1. Okay, I'm going to take care of the charge before I start to bond. This physically, to become positive 1, must have lost an electron. I'm going to take that away from nitrogen. So why don't I undo what is the pair? Each hydrogen we know will make a single bond. Nitrogen, since it started with 4, will need 4, and how perfect. So no lone electrons on nitrogen. And I need to show this is positively charged. All right. Let's go on to BrO3 minus. So bromine, we know we'd start with it having 7. Then we have 3 oxygens, each with 6. But my -1 will cause me to put another electron on bromine. Oh my gosh, so it is actually beginning with 8. It already has its octet. I will let us know when something exceeds the octet. Bromine is not here, otherwise I would tell you. Now in AP chemistry, we're going to learn some other things, but for us now, we're just going to handle the construction, not violating anyone's octet. Bromine already has 8. But each oxygen needs 2 more. So how do we do that? Well, in the previous video, we learned about coordinate covalent bonds. So what if we just allow oxygen to keep all the 6 that it brought? And then we use the electrons of bromine. So these 2 came from bromine to make the bond. So I'll just move that one of bromines over and make the bond. How about this 1 electron of bromines over and make the bond? Then bromine still has 8, and then each oxygen has 8. I just need to show that there's an abundance of 1 more electron. The coordinate covalent bonding will happen in this to create this structure. Now again in AP we'll learn some different things, but for now that is good to go. And sulfur will do coordinate covalent bonding with oxygen. So to make these single bonds, the electrons came from sulfur. And I need to show that that's a -2. Now this one's just a little harder. So nitrogen. We would start out by assigning it 5 valence electrons. Our 3 oxygens we assign to begin with 6. I need to assign another to nitrogen to handle that -1 charge. All right. Nitrogen needs 2 more. Each oxygen needs 2 more. Here's a tip I have. If your structure has more than 1 oxygen, try satisfying the bonding of 1 oxygen at a time, not all at once. Well, I'm going to start with this. Oxygen needs 2 more, so I think double bond. Let's just try that. So we'll make a single bond from 1 electron from nitrogen, 1 from oxygen. Another bond, 1 from nitrogen, 1 from oxygen. That satisfies this oxygen. But then that also ends up satisfying nitrogen. Nitrogen, 2, 4, 6, 8. So now, what if we coordinate covalent bond? So let's let oxygen keep its 6. And let's make bonds, the remaining single bonds with the electrons from nitrogen. So these were just maybe a bit easier because you went right to the coordinate covalent bonds. This, you had to work to get there. It's just a little harder. Those are how we do polyatomic ions.